Okay, so we're going to have a look at 6.2 today, which is reverse chain rule. My apologies if I cough at any point, I'll try not to. I'm going to do 8 examples. They're kind of in pairs, so like 1 and 2 are similar and 3 and 4 are similar, but it's just showing you a kind of slightly more difficult version. It might be worth you writing down all 8 if you feel quite stuck with this, or maybe the alternate ones if you're feeling more confident, or you might want to watch the entire thing through and then go back and copy up the ones that are relevant. I'll add the answers and the examples all to OneNote during lesson 2 whilst you're working, so if you just prefer to have the reference there, you can as well. The main thing about this topic is to just really get practicing with it. Sometimes you'll have a go at thinking about the type of, like the starting point for the integration, and it might not quite be right, but that's okay, just try something different. Okay, so example 1. Let's say we're going to integrate 6 cos 2x dx. Okay, so have a think about what differentiates to make cos, and obviously it's sine. So let's start, and we'll have a think, and we'll try and start with sine of 2x. So let's differentiate that and see what we get, and then see what we need to adapt to make it the answer. So dy by dx will be 2 cos 2x according to the chain rule. Okay, well I need 6 cos 2x, so I must have needed 3 sin x plus c to start off with. Example 2. So if we have 5 sine of 3x, well, in order to get sine, we must have differentiated cos. But when we differentiate cos, we get minus sine. So what we'll need to have a think about is, I must have needed minus cos of 3x in order to get sin x. So if I differentiate this, then I'm going to get 3 sine 3x. Well, I need 5 sine 3x. So if I multiply it by 5/3, that will give me my 5. So I will need minus 5/3 cos of 3x. Example 3. Let's integrate 24 bracket 2x minus 3 all cubed dx. So let's just start off with the bracket. That's a really good starting place when you have these sorts of questions. So we must have started off with 2x minus 3 all to the power of 4. Remember that we raised the power. So let's differentiate that and see what we would get. So we'd bring down the 4. That would give us 4 bracket 2x minus 3 cubed. And then we'd have to multiply it all by 2. It's all in the wrong order, never mind. So that would give me 8 bracket 2x minus 3 all cubed. So I need 24, not 8. So I need to multiply my whole answer by 3. That would give me 3 bracket 2x minus 3 to the power of 4. Okay, this is example 4. So 20x squared bracket x cubed plus 7 all to the power of 4. So this looks a little bit of a complex example, but let's just start off with the bracket. So we'd raise the power, so that would give us x cubed plus 7 to the power of 5. When we differentiate that, we'd get 5 bracket x cubed plus 7 to the 4, and then we'd have to multiply it by the bracket differentiated, which is 3x squared. So that would give us 15x squared bracket x cubed plus 7 to the 4. Well, I want 20, not 15. So if I multiply 15 by 4/3, then I'll get 20. So my end answer is 4/3 bracket x cubed plus 7 to the power of 5 plus c. Example 5. So let's integrate 10 e to the 2x dx. So let's start. We'll take the e to the 2x and we'll differentiate that to start off with. So that will give us 2 e to the 2x according to the chain rule. Okay, but I need 10, not 2. So I multiply 5, and that will give me my 10. So I have 5 e to the 2x plus c. Example 6. 8x e to the x squared dx. So let's integrate this. So we're going to start with thinking about e to the x squared, because that will be our kind of main function. We know on the chain rule. So we start with e to the x squared. When we differentiate that, we'll get 2x, because we need to differentiate the power, e to the x squared. Well, I need 8. So I need to multiply that by 4. So that will give me 4 e to the x squared. One really good thing to test is once you've actually integrated it, try differentiating it back and see if you get the right answer. That's a really good strategy with these sorts of questions. Okay, example 7. 3 over 3x plus 2 dx. Okay, so just think about the bottom. The bottom in brackets would be 3x plus 2 to the minus 1. If you get anything to the power of minus 1, then it must have been natural log to start off with. So let's just have a look at the ln of 3x plus 2. So if I differentiate this, we'll get 1 over 3x plus 2, and then we have to multiply the whole thing by 3. So that's 3 over 3x plus 2. Oh, well, that's our answer, so that was easy. So it's ln of 3x plus 2 plus c. And lastly, example 8. So we have x squared over 2x cubed plus 7. Again, think of the bottom in brackets. So the bottom in the brackets would be 2x cubed plus 7 bracket all to the power of minus 1. So we must need a natural log. So y equals ln of 2x cubed plus 7. So let's just differentiate that and see what we get. So we'd get 1 over 2x cubed plus 7 multiplied by the bottom differentiator, which gives us 6x squared. That looks very similar to what I need, but the whole thing is multiplied by 6. Remember, when you multiply a fraction, that affects the numerator, not the denominator, because it's a bit like having 6 over 1. So I need a sixth of that answer in order to get my sort of desired integral. These just take a little practice, so you have to start off with the question. Think about what you probably used in the chain rule to get the answer, and then adapt by multiplying it by potentially another number or a fraction to kind of fit it to your answer. It does take a bit of practice, but the more of them you do, the more confident you'll feel. If you have any queries, you can either email me or go on to the Yammer group if you haven't already, and then you can message me on there. But hopefully between you all, you'll be okay. But if you do have any problems, please email me and I can send you some more examples.